All right, so here we go. Example number 2 underneath functional notation. We have 3 functions here, f of x, g of x, h of x. Again, it would be confusing if they all said y equals, y equals, y equals. I want to remind you that the functional notation is just a replacement for y to avoid confusion, to help us to tell these equations apart from each other, to distinguish them from one another. And again, the f and the g are named after my twin daughters, Frida and Gertrude. We looked at them on the previous example there. Hi, girls. And then, of course, you know that the h of x would be their mother, my lovely wife, Helga. And that's Helga Jr. actually right there. So I have 3 daughters, Frida, Gertrude, and Helga Jr. there. She would be the one on the far left. So anyway, I'm going to get in trouble. Here we go. So use these 3 functions to determine the following. H of smiley face. Okay, I just wanted to get across the idea that first of all, the h is asking us to use that function over there, and we're going to do what? It's just a pattern. H of something, that something takes the place of x. This is like a pattern to follow. So this would be 7 times smiley face to the 3rd power. Smiley face takes the place of x. Minus 5 times smiley face squared plus 2. That's it. All right? So whatever's in the parentheses takes the place of x. That's the main thing to take from this. That would be fine as far as I'm concerned. I didn't give you homework like that. I'm just proud that I was able to figure out how to get a smiley face into PowerPoint. Quick little story. I had a student one time that said, hey, I can change that. And I'm like, no, you can't subtract those. They're not like terms. And anyway, they called me over and I looked at their paper, and this is what they had done. I don't know how well you can see this, but anyway, what's that? 7 smiley face cubed? Pretty good. Minus 5 times smiley face squared plus 2. Anyway, no homework like that really, but there you go. All right, so not that big of a deal. And that would be the first one. We'll call that example 2, part A. All right, let's go ahead and do this first column of examples. Part B says g of 4. That's how you say that, by the way. G of 4 minus f of 7. All right, so I would look at this as 2 separate parts to the question here. And so, for example, g of 4, I've learned that if I shape these, it keeps the ink better. All right, so if you're wondering, so g of 4, isn't that saying to go to the function named after Gertrude and put 4 in for x? So wouldn't the work there be g of 4 equals 2 parentheses 4 squared minus 5 parentheses 4 minus 3. 4 takes the place of x. And then crunch the numbers, which is important, but that's old stuff. 16 times 2. You do the exponent before you multiply. Day 1, all right? Oh, that is so January. And then 5 times 4 is 20. Whoops, minus 3, pardon me. And 12 minus 3, I think that's 9. All right, so the point is, I've heard people compare functions to machines. 4 was the input, 9 was the output. Functions convert one thing to another. Oh, I don't know, like maybe Celsius to Fahrenheit, that kind of thing. All right, so I think if you put 4 into that function, it spits out a 9. All right, minus, okay. And then the other part of the question is what? Go to the function named f, the one named after Frida over here, and put 7 in for x. See, it's very concise. It identifies what equation to use, and it tells us what to put in for x. So f of 7 would be 4 times 7 minus 3, 28 minus 3, 25. So that part of the question spits out a 25. You put 7 into that function, it spits out a 25. This could be any operation we wanted between the two. I decided to type minus when I made up the question. So anyway, that would be negative 16 for a final answer for that part of the question. So I'm hopeful that these are simple for us, and I don't know. All right, so why don't we do example 2, part C, and then we'll pause for a minute. Speaking of pause, hit pause anytime you want. You can stop and zoom in. I don't know. This might, I don't know, just think about the time you would be driving here. So take your time, You'd be spending time driving down here, so you might as well use that time to watch these examples nice and slowly and hopefully understand them. So what's this? F of 6 over h of 2. So again, I would consider the two parts of the fraction to be their own groups, right? So f of 6, the numerator, go to the f function and put 6 in for x. Easy. F of 6 would equal 4 parentheses 6 minus 3, which is equal to 24 minus 3, which equals 21. So you put 6 into that function, spit it out, 21. Numerator's 21. Okay, no big deal. I hope you find these to be very easy and, dare I say, fun. All right. And then h of 2. Oh, go to h, put 2 in for x. Here's h, right? Helga Jr. So h of 2 would be 7. Put 2 in for x, right? So here we go. 7 parentheses 2, third power minus 5, parentheses 2, squared plus 2. Crunch the numbers. Exponent, then multiply. 2 cubed. 2, 2, 2 is 8. 2 times 2 times 2 is 8. 8 times 7, 56. All right, 2 squared is 4. 4 times 5 is 20. Exponent before multiply. That's the order of operations. And then this would be left to right. That'd be 36 plus 2. It looks like 38. So that denominator comes out to be 38. And so you put 6 in here, you get 21. You put h over there, you get 38. You put 2 in h, you get 38. 21 over 38. That fraction won't reduce. I think we're done. So I hope you would agree with me that it's not a coincidence that the word function begins with the word fun, right?
Let me spell it for you. F is for friends who do stuff together. U is for you and me. N is for anywhere and any time and other.
F is for fire that burns down the whole town. U is for uranium. Bombs. N is for no survivors when you're...
Well done. Those things aren't what fun is all about. Now, do it like this. F is for friends who do stuff together.
That's completely in the...
All right, well,
Here, put me
I
up.
think you get the
F
idea.
is for friends
We'll
who
call that
do
good.
stuff together.
U is for you and me.
Try it.
N is for anywhere, anything you know. Out here in the deep blue sea. Down here at ACC.